Good morning, everyone. Thank you for inviting me to this conference and for giving me this opportunity to speak here today. My name is Ben Wang, and I am from the Hiroshima University. Today, I will share the topic with you. Topic and sentiment analysis, matrix factorization, and rating prediction for recommendation. So let's get started. This is outline. First, I will give a brief introduction about the matrix factorization method and the latent factor model. Nowadays, most of our web surveys are using various recommender systems, including the famous Amazon, YouTube, and so on. Let's take Amazon as an example. A user's feedback may mainly include 4 pieces of content, like the user's rating, the review, the time, and the number of the positive votes. The positive votes are upvoted to the review by others. The feedback is so significant for us to link the user and the item. Next, I will introduce a widely used approach, collaborative filtering. It is the most effective method for predicting rating. It assumes that users with similar interests are also interested in the same items. It often can be divided into 2 methods, the member-based and the model-based. Since the member-based methods are more common and basic, let me take one of them, the user-based method, as an example. We can see in the slide. For the user 3 and user 1, they have all both the item 3 and item 5, so we consider they are similar, and we recommend the item 1 and item 6 to the user 3. As a new method, today I will introduce more about the matrix factorization, MF. MF is an ideal approach used to fill in all the blanks in the user item matrix. If we can fill in all the blanks, we can recommend the item with highest rating to the users. However, if there are so many users and items, and it will become a sparse matrix, how can we depose it? The latent factor model is the most effective method used to depose the matrix into 2 submatrices. So the predicted rating of the user I related to the item J is U times V. The main process of the algorithm is to initialize 2 matrices randomly and then use the exit feedback to get the final model through the SGD training. Based on the MF model, we propose the sentiment combination matrix factorization, SCMF model. They have 2 features. The first one is we use topic and sentiment analysis methods to directly establish 2 submatrices based on user reviews. Another one is we add the reliability measure into the objective function for optimization. Let's dive into it. This is architecture diagram of the entire model. The left part is the pre-processing part of the system. On the right is a core part of the system, the training part. And finally, the lower right corner is the prediction rating part. As you can see, we use the product of the 2 fixed matrices, x, y, and the weights to predict the rating instead of the original submatrices. Later, I will show you how to get them. And then we can see the yellow part in the middle of the slide is the reliability measure, which is got from the operation of pre-processing. It consists of 3 parts: the positive vote ratio, rating, and the sentiment score. The positive vote ratio is the evaluation from others, and the distance of rating and sentiment score is the evaluation from the user themselves. So they are so important for measure users. It can be denoted as the WS, and we can add it into the objective function to obtain a new objective function. For the generation of two submatrices X and Y. It is obtained by each user and each item through a series of calculations. First, we take all the reviews of each item as a whole and use a good topic analysis tool, LDA method, to get the item topic distribution vector theta. We can calculate all the items and merge them vectors into a matrix. Then, for the user, we calculate the sentiment analysis results of each review corresponding to each user and item, times it by the theta corresponding to the item just now, and finally add up them together and average them to get the user preference distribution vector row. In the same way, we can calculate all the users and merge them vectors into a matrix. In the experiment, we take RMSE as indicator with 8 Amazon user reviews datasets to compare 6 baseline methods with our proposed method. The RMSE is used to measure the deviation between the predicted review and the true view. The smaller the view, the better result. From the results, the proposed SCMF method obviously outperforms the others on all datasets, except musical instruments, and shows the best improvement of 19.17% compared with MF unvaried. Also, we performed a t-test on the results and shows that there is a statistical significance between the results of SCMF and the other methods. Therefore, in conclusion, we integrate the reliability measure and the topic and sentiment analysis or reviews into the matrix factorization framework for prediction and get the outstanding performance. In the future, one consider using the textual reviews to model the context attribute as Z, similar to the X and Y construction method. Also, we'll consider the construction relationship between X, Y, and Z to predict the user rating behavior more accurately. Thank you for listening.